And so here we have log base a of 9 halves. So what we first want to do is expand these. So if we take log base a of 9 minus, or that's a positive, the 9 is in the numerator, so it's a positive in front. Log base a of 2 is a negative because that 2 is in the denominator of a fraction. And now I can see I can replace this log base a of 2. So I can substitute in a 0.541 for that. But I have this log base a of 9. Right? So I don't have it in terms of 3, but what can I do? Can I express 9 in terms of a 3? Yeah, 9 is, if I take 9, I can rewrite it as 3 squared. And so by doing that, by changing this 9 to a 3 squared, and then applying the properties of, we can remove a power from inside a log and write it as the coefficient in front. I now get 2 times my log base a of 3, which has a value I can substitute, 0.213. And so here's my calculation. If I find the numerical value, 2 times 0.213 minus 0.541, and that gives me my answer of negative 0.115. And so that would be my evaluated, or my evaluation for that expression. Okay. So when you look at this, if you expand it first, log base a of 4 is positive because 4 is a factor in the numerator. Log base a of 3, 3 is in the denominator, so we're going to have a negative in front of this. So we can replace the log base a of 3, but not the 4. But can we rewrite the 4 in terms of this base 2? Yeah. So it's the same idea, 2 squared in this particular case. And then move our power, or a power of 2 out in front of our log. And now you can substitute in. So 0.541 for log a of 2. 0.213 for log base a of 3, and now we can just we can calculate our values, and we get 0.869 as our overall evaluation.